Thank you for joining my presentation today. I'll be presenting on the comparison of the bilateral and unilateral barbell hip thrust. As we see in this slide, we see an example of both the bilateral and unilateral barbell hip thrust. The bilateral where the bar is raised with both lower limbs, and the unilateral variation where it's raised with a single limb. As with most lower limb resistance training, the research has focused primarily on the bilateral variations. Contreras et al. Introduced an EMG study to the literature in 2015. Contreras et al. Showed that the barbell hip thrust produces high EMG activity at the upper and lower glute as well as the bicep femoris. Contreras et al. Also showed that the barbell hip thrust improved 10 and 20 meter sprint performance to a greater extent than the barbell front squat in an 8-week training program. Bezodis et al. Through SPM methods showed that the barbell hip thrust produces significantly greater hip joint extensor moments later on in the repetition phase when compared to the barbell deadlift and barbell back squat. Therefore, the aim of this study was to quantify the hip joint kinetics and kinematics of the unilateral barbell hip thrust and perform a biomechanical comparison with the bilateral barbell hip thrust at the same relative external load. The purpose of this study was to help inform exercise selection for loading the hip extensor musculature. For this study, 10 resistance-trained males with a minimum of 6 months training experience with the bilateral and unilateral barbell hip thrust performed 3 sets of 3 reps at a 10 repetition max intensity. This intensity had previously been set in research by Contreras et al. Kinetic and kinematic data was collected with a 15 camera Vicon system and 3 Kistler force plates, 2 floor mounted force plates and a force plate mounted to a custom made rig at a height of 20 centimeters and angled at 20 degrees to the horizontal. Data was filtered at 6 and 80 Hz for the marker trajectories and force data respectively. Data was tracked and gap filled using the Vicon Nexus software, and clean trials were then exported to Visual 3D for calculations and filtering to be done. The force plate mounted to the custom made rig, as previously discussed, was rotated and resolved in the global coordinate system. Joint angles, angular velocity, moment, work and power were calculated in Visual 3D with the onset of each repetition occurring with the raising phase, starting with the hip joint angular velocity exceeding and then remaining above 0, and then the end of the lifting phase and the start of the lowering phase with the barbell at its maximum vertical displacement. Waveform data for the joint metrics were normalized to 100% of the repetition time, and means and standard deviations were calculated. For the bilateral condition, results were averaged over the left and right leg, and for the unilateral condition, results were averaged over the lifting and non-lifting leg. The joint kinetics were normalized to body mass, and due to the non-parametric nature of this data set, a Mann-Whitney U-test was used for difference testing. Kinematically, we see similar patterns in the sagittal plane as seen in figure 1a. The differences we do see are that the bilateral position seems to create a more extended position throughout the repetition at the hip joint. In figure 1b, we see a similar pattern for both the bilateral and unilateral barbell hip thrust for angular velocity. Although not to a statistically significant extent, there is greater peak angular velocity in the raising phase for the bilateral condition. In the transverse plane, we see that the unilateral condition produces greater peak external rotation and peak internal rotation. These were both to a statistically significant extent over the bilateral condition. Kinetically, we see a greater mean and peak moment in the sagittal plane for the unilateral condition, with a statistically significant difference for mean moment. We also see greater frontal peak moment in the unilateral condition that should be noted. We also see a statistically significant difference for sagittal positive work done in the unilateral condition over the bilateral condition. Kinematically, we saw a lot of interesting results in the transverse plane, with a twofold increase in the internal rotation observed for the unilateral condition compared to the bilateral condition. It is hypothesized that the reduced base of support associated with the unilateral exercises increases the demand of control about the hip joint. This is supported by research by McCurdy et al. The single base of support also increased moments in all three anatomical planes, as well as increased mean moment in the sagittal and transverse planes. This suggests that there may be increased loading of the hip rotator musculature as well as extensor musculature. As participants were instructed to complete the repetitions of the exercise as they normally would in a habitual training environment, flexion and extension, therefore raising and lowering, was not controlled. It is hypothesized that the lower angular velocity in the sagittal plane in the unilateral condition may have occurred due to the additional stabilization requirements about the hip joint during the raising and lowering in the unilateral condition. In order to allow participants to maintain a level pelvis and therefore not drop the barbell either side and maintain a level pelvis in the unilateral stance, the results produced indicate that an increased requirement of both the hip extensors and the hip rotators was required. This aligns with findings by Stevens et al. That unilateral exercises elicit greater activation levels than their bilateral counterparts. Interestingly, the greater joint moments in the unilateral condition were achieved with a load that was approximately 30% of those used in the bilateral condition in terms of physical weight on the barbell. The results for joint moment showed that the unilateral variation of the barbell hip thrust offers greater multiplanar mechanical loading of the hip joint compared to the bilateral variation. The kinetic results, as well as the results for angular velocity, suggest that the unilateral barbell hip thrust requires greater stabilization about the hip joint. The findings of this study will help inform coaches and rehabilitation practitioners when prescribing barbell-loaded bridging exercises. Thank you for watching my presentation today. I look forward to hearing from you through the channels listed on the bottom of the slide shown.